Today we're going to learn a handy tool that we use to calculate equilibrium concentrations or calculate the value of K if we're not given equilibrium concentrations. And so what we're going to learn today, you guys, is how to make an ice diagram. And we will look at over the next 2 months the many ways that we will be able to utilize this thing to help us solve problems. So our title is simply going to be ice. And today is 27th. No, it's not. Is it? Yeah, 27th. Okay. So, let's start with this problem. Suppose that the methanol synthesis reaction is carried out with the following initial concentrations. Okay, so a methanol synthesis. Methanol is an alcohol, OL, so it's going to have an OH group at the end, and an alcohol functional group, and meth, meaning that there's one carbon. So this synthesis is carbon monoxide, get the whole thing here in front of me, gas plus hydrogen gas reacts to give me methanol. That's the methanol gas. Okay, so we're in a closed container. We've got some gases here, and this thing is going to reach an equilibrium. All right, so what are our concentrations of everything? To start out with, the the carbon monoxide concentration is 1.75 molar. The hydrogen concentration starts out being 0.80 molar, and the methanol concentration actually begins at 0.65 molar. Okay, so this reaction is going in a vessel, and there's already product there. Okay, so there's 1.75 molar carbon monoxide, 0.8 molar hydrogen gas, and 0.65 molar methanol. Okay, at equilibrium, we find that carbon monoxide concentration is equal to 1.60 molar. Okay, so we're given initial concentrations, and we are given the concentration of one of the components at equilibrium. And what we need to do is calculate the value of K. Calculate the equilibrium. do, first thing we always do in going after an equilibrium problem is we are going to write the equilibrium expression. So K is equal to products CH3OH over reactants okay, everything's gaseous, and there we have it. That's our equilibrium expression. Okay, now, we need to solve for K. That means that we need the equilibrium concentrations of these three components. Now, we are given the equilibrium concentration of one of them. So we know at equilibrium, the concentration of carbon monoxide is 1.6 molar. And so what we need to do is, from that piece of information and from the initial concentrations, we should be able to figure out what our equilibrium concentration for hydrogen and for the methanol is. So how do we do that? How do we figure out those equilibrium concentrations for our unknowns? Well, we're going to set up an ice diagram to do that. And so it is going to look like this. I always put the balanced equation at the top. Carbon monoxide gas plus 2 hydrogen gases to give me some methanol. Okay, and here comes the ice part of it. So, we say initial change and equilibrium. ICE, an ice diagram. Okay, so let's just go with this. My initial concentration of carbon monoxide is 1.75. My initial concentration of hydrogen is 0.80. My initial concentration of methanol is 0.65 molar. Now, what's the only other thing that I know that I can fill in here? Well, I know the equilibrium concentration of carbon monoxide. 1.60. Now, this tells me then that I've lost 0.15 molar carbon monoxide. It has been utilized to create product. So the change in my concentration is minus 0.15. Right? These are all concentrations, but we can just look at these as just being regular old numbers. So that initially it started with 1.75. I end up with 1.60 at equilibrium. So that means that I lost 0.15 molar carbon monoxide. Right? It got converted into product. Now, if I lost 0.15 of carbon monoxide, these are in a 1:2 mole ratio. So that means I lost twice as much, or I utilized twice as much hydrogen. And so I'm going to say twice 0.15 is what I lost here. right? Because they're in a 1 to 2 mole ratio. So what is this overall, you guys? It's 0.30. Twice as much as this. 2 times this amount. So what do I have at equilibrium? 0.50. I'm going to put right here 2 times 0.5. That's what that is. Okay, now if I lost 0.15, and these are in a 1 to 1 mole ratio, what happens here? I'm going to gain or make 0.15. So at equilibrium, I'm going to have 0.80. All right, so I have all my equilibrium concentrations, and my job is to calculate K. So what am I going to do with these numbers? I'm going to plug them into my equilibrium expression to solve. So K is equal to 0.80 over 1.60. I'm just going to put parentheses around all these so that we don't get confused. And my equilibrium concentration for hydrogen is 0.50. And what am I going to do with that quantity? I'm going to square it. And that gives me a value for K. That is